Right, Saj. Hello everyone, welcome to MK Academic Solutions. So in this video, I am going to explain you first order gas phase reaction. Yesterday in the last class, I have explained you about the first order reactions. Okay, we know what is the first order reaction. If n is equal to 1, that is called what? First order reaction. Now we are going to see gas phases. Okay, this is also sometime they will give. Okay, let us consider A gas is giving rise to B gas plus C gas. It follows the first order kinetics. It follows first order kinetics, like that we consider. Okay. So now here it is a gas, it is also A also gas, B also gas and C also gas. Okay. At a time t is equal to 0, means at initial time. Okay, at initial time time t is equal to 0, pressure exerted by this gas A is called P naught. Means why? Because only pure A gas is there, that's why we are going to consider P naught. And here pressure exerted by B is 0 and pressure exerted by C is also 0. Next, at time t is equal to t, means after some time. So some of the reactant is converting into product, means the partial pressure of A is going to be, the pressure of A is going to be decreased. So how much we are considering here? P naught minus P. This much pressure is decreased, and how much pressure of B increased and how much pressure of C increased, that is P. Okay, right. So now we know according to the rate constant of first order reaction. What is the rate constant of first order reaction? That is K is equal to 1 by T ln initial concentration. What is the initial concentration? P naught, means initial pressure is P naught. Okay, initial pressure is P naught and by pressure at time t. What is the pressure of gas at time t? P naught minus P. Okay, P naught minus P. Okay, this is the rate constant for first order reaction in gas phase. So here this value also, P value also we can find by using the total pressure of gas. Okay, so P value or P naught minus P, that is what? Partial pressure, or else is directly you can take partial P naught minus P. P naught minus P is equal to here partial pressure of A, partial pressure of A. So that we can consider as that is equal to PA. Partial pressure of A is equal to PA. So this partial pressure of A we can find by using the total pressure formula. So here what is the total pressure at time t? So total pressure at time t. So what is the total pressure will be? Total pressure means pressure exerted by A, pressure exerted by B and pressure exerted by C. That is called total pressure. So P total, PT. So here what is PT? Total pressure. That is equal to partial pressure of A, P naught minus P, plus partial pressure of B, partial pressure of C. Okay. So what is the partial pressure of B? We consider P. Partial pressure of C also we are going to consider as P. So now therefore total pressure PT is equal to so here minus P plus P will get cancelled out to P naught plus P. Total pressure is what? P naught plus P. So therefore we want P pressure. So means how much pressure is decreased, that we want. So therefore P will become, P is equal to Pt minus P naught, Pt minus P naught. So now substitute the P value in this equation. So now we know what is the P value. P value is Pt minus P naught. Substitute that value now. So here when you substitute, that is K is equal to 1 by T ln P naught by P naught minus P. P value, what is the P value? Here we are having P value, that is Pt minus P naught. Okay. Therefore, K is equal to 1 by T ln P naught by P naught minus into plus minus Pt minus into minus plus P naught. Okay. Total, this equation will become K is equal to 1 by T ln Pt P naught by P naught plus P naught to P naught minus Pt. Okay. So this is the rate constant for the first order gas phase reactions. Okay. Sometime directly they will ask you. Okay. Right. Okay. Next, let us discuss about the rate constant for the nth order. So up to now I have explained in previous classes rate constant for the zero order, first order and first order gas phase reactions. Okay. Next, let us go to the rate constant for nth order. Okay. Next, we are going to discuss about the rate constant. Rate constant. Rate constant. Rate constant. Rate constant for nth order. Nth order and half life of nth order, half life of nth order reactions. Okay. Rate constant of nth order and half life of nth order reactions we are going to discuss. So here this rate constant for nth order is applicable for the second order reactions, third order reaction and negative order. So generally we will not discuss about the negative order. Finally the total order will be what? Positive only we will get. Third order and also fractional order. Fractional order means 1 by 2, 3 by 4 like that. These are what? Fractional order. This is rate constant for the nth order reaction is applicable for what? Second order, third order, fractional order. We know what is the second order reaction. If n is equal to 2, if order of reaction is equal to 2, that is called second order reaction. Third order reaction, order is equal to 3. Okay, right. Now let us see rate constant of nth order reaction. Let us consider A is converting into B. A is converting into B, or simply you take A is converting into product P. A is converting into product P. So here rate of reaction, rate law for this reaction, rate is equal to K into A power n. So here n may be second order, first order or fractional order, but not zero order and first order. Okay. So here n is equal to 2 or 3 or fraction, but n is not equal to 0 means first zero order and n is not equal to first. Okay. So now consider like this. Okay. This is very important thing you need to keep in mind. Again, this nth order rate constant is not applicable for the zero order reaction and first order reaction. That also you need to keep in mind. So here what is the rate? Rate formula is what? Minus dA by dt is equal to K into A power n. K into A power n. Okay. So now minus dA by A power n that is equal to k dt. Okay, k dt. Now let us do the integration of this equation. So when you do the integration of this equation, how you will get, children? So simply, so for the sake of convenience, this minus sign you send that side. Okay, so now it will become dA by a power n, that is equal to minus k dt. So now let us do the integration. So now let us do the integration of this equation. So how we will get the integration formula, integration here, by taking the limits. By taking the limits, initial concentration A and final concentration is A minus x. Like that only we are going to consider now, children. So your initial concentration means at a time t equal to 0, we are going to consider A. At a time t is equal to t, A minus x. Okay, we know this very well. So this is the initial concentration and final concentrations. Okay, these are the limits. Okay, so therefore how we will get here? So dA by a power n, that is equal to minus k here dt. So how we are going to integrate this time is at time t is equal to 0 to time t is equal to t. Okay, so now this we can write as a minus x. Okay, integral a minus x, a to a minus x, a power minus n dA, that is equal to minus k integral dt. Okay, right. So now what is the formula of this? So now let us apply the formula for this. So here what you will get here? You will get a minus x, a minus x power minus n plus 1 by minus n plus 1 minus a power minus n plus 1 by minus n plus 1, that is equal to minus kt. Okay, you will get like this, minus kt. Okay, so now here minus n plus 1 you can take common, so it will become as 1 by 1 minus n, 1 minus n into a minus x power minus n plus 1 minus a power minus n plus 1, that is equal to minus kt. Okay, so now what you can do here? 1 by 1 minus n, this you can write as 1 by a minus x. Okay, so here initially it is in the numerator, and when you bring the denominator, power will become inverse, means we need to multiply with minus 1. So now it will become as a minus x power n minus 1 minus 1 by a power n minus 1, that is equal to minus kt. Okay, therefore minus and t you send this side, it will become as minus 1 by 1 minus n into t 1 by a minus x power n minus 1 minus 1 by a power n minus 1, that is equal to k. Okay, so now here this numerator and denominator you multiply with minus, then how you will get the equation, children? Here numerator and denominator you multiply with minus, means so minus into minus plus. Okay, minus into minus will become what? Plus 1 by, so when you multiply this n minus 1 will become 1 minus n 1 will become n minus 1 into t. Okay, 1 by a minus x power n minus 1 minus 1 by a power n minus 1, that is equal to k. Right children. So this is about what? Rate constant for the nth order reaction. Okay, what is the rate constant for the nth order reaction we got here? That is 1 k is equal to 1 by t n minus 1 into k is equal to 1 by n minus 1 into t of 1 by a minus x power n minus 1 by 1 by a power n minus 1. Okay, so now let us write that in another phase. Okay, so now here how we got here? K is equal to 1 by n minus 1 into t 1 by a minus x power n minus 1 minus 1 by a power n minus 1. So this is the rate constant for nth order reaction. Now let us see the half life of nth order reaction. Half life of nth order. Half life of nth order. Half life means children, half life means t is equal to t 1 by 2 and a minus x. This total value will become a by 2. Okay, a minus x will become how much? A by 2. We know this. So here what is the half life means? The time required to conversion of half of initial concentration. Okay, so here we are going to take initial concentration is a, and here a by 2 means half of the initial concentration. Time required for converting half of the initial concentration, or time required for the consuming of half of initial concentration is called half life of the reaction. Okay, now let us substitute these values in that equation. So now here actually we know k is equal to 1 by n minus 1 t. In place of t what I need to write children? T half 1 by, in place of a minus x what I need to write? A by 2. A by 2 to the power n minus 1 minus 1 by a power n minus 1. Okay, this is the equation you will get here. So here k is equal to 1 by n minus 1, or else in place, now you send the t half that side. Okay, so here you take t half is equal to 1 by n minus 1 k, 1 by n minus 1 k. So it will become 2 power n minus 1 by a power n minus 1 minus a power n minus 1. Okay, so here this is the similar fraction. How we can write this similar fraction? T 1 by 2 is equal to 1 by n minus 1 k 2 power n minus 1 minus 1 a power n minus 1. Okay, so now here n is constant. Okay, n will become constant here, and minus 1 also will become constant. Minus 1 also will become constant, k also constant, 2 power n minus 1 and this minus 1 also constant, and you remove total constant. When you remove the total constant, so how you will get? T half t 1 by 2 is proportional to 1 by a power n minus 1, or else you can take t 1 by 2 is equal proportional to a power 1 minus n. Okay, So this is the formula. It is applicable, this T half is applicable for any type of reaction. T half is applicable for T half is applicable for applicable for any type of reaction, any type, means whether it is first order, zero order, no matter. What is the T half? T half is directly proportional to a to the power 1 minus n, or T half is inversely proportional to 1 by or proportional to 1 by a power n minus 1. This is about what? Half life of nth order reaction and rate constant for the nth order reaction. And one more what I have explained to you, that is first order gas phase reaction. So what totally what I explained to you, the first one is here first order gas phase reaction, rate constant. So here K is equal to 1 by T ln P naught by 2 P naught minus Pt, and then after rate constant for the nth order reaction. So this will be the rate constant for the nth order reaction. It is applicable for what? Second order, third order, and fractional order. Fractional order you can take. And half life of nth order reaction. So here by taking this rate constant of nth order reaction, I have derived you, okay, half life of nth order reaction. But half life is applicable for what? Any type of reaction, okay, like 0, first order, second order, third order, even for fractional order also it is applicable, okay. So this is about total information about the order of reaction, okay. So thank you for watching, and we will continue our lesson in next class, okay.